Alright, so before we start with Neuro-Fuzzy system, we know that in fuzzy inference there are few processes that involve, right? We have four processes. One would be fuzzification process. Second one is the rule evaluation. The third one is aggregation, and last is defuzzification process. So all of this fuzzy inference process will be incorporated into our Neuro-Fuzzy architecture. So in here we have 5 layers. Layer 1 will represent input layer. So you know that if you take a look at here, you have two x1 and x2 here. So these represent the fuzzy variable. So say here you got two variable here. For example, we have temperature and also another one possibly be blood pressure. Okay, so in layer 2 as the fuzzification layer, this is fuzzification layer, all of this will represent the fuzzy values, right? So say you have here temperature, possibly the values would be cold, medium, and also hot. Okay, representing A1, A2, and A3 here. Okay, so next would be the fuzzy rule layer. Okay, in fuzzy rule layer, so these are all the rules, if then rule, that incorporated from your fuzzy variable and your fuzzy values. Next is the output membership layer, and this one is, if this is if part, this would be the then part, and layer 5 would be the defuzzification layer. So move on to the explanation for each layer here. So each layer in Neuro-Fuzzy system is associated with a particular step in fuzzy inference process. Those four processes that we have seen in previous slide. So layer 1 is the input layer, where each neuron in this layer will transmit external crisp signal directly to the next layer, so that this crisp signal will be fuzzified in the second layer here. So layer 2 is the fuzzification layer, where neuron in this layer, okay, you have two neurons, right? Just now you have seen neurons. Okay, represent the fuzzy set used in antecedents. Okay, so here this is not two neurons, so you have 1 2 3 4 5 6 neurons. Okay, so use it is a fuzzy set or the fuzzy values used in the antecedent of fuzzy rules. A fuzzification neuron will receive a crisp input from layer 1 here, okay, and determine the degree to which this input belong to the neuron fuzzy set. So the activation function of a membership neuron is set to the function that specifies the neuron fuzzy set. So we use triangular set, for example. So the activation function in layer 2 here, in fuzzification layer here, would be set to triangular membership function like this. Okay. So next layer is layer 3. Layer 3 is the fuzzy rule layer, where each neuron in this layer will correspond to single fuzzy rule. A fuzzy rule neuron will receive input from fuzzification neuron, that is from layer 2, that represent the fuzzy set in rule antecedent. So for example, neuron R1, okay, will correspond to rule 1, and it will receive input from neuron A1 and B1 in layer 1. Okay, in layer 2, sorry. So in a Neuro-Fuzzy system, intersection can be implemented by using the product operator. So the output will be like this. So for example, in rule 1, So what would be the product? It will be the product operator of A1 with B1. Layer 4 is the output membership layer. Neuron in this layer will represent the fuzzy set used in the consequence of the fuzzy rules. So the then part, okay. The output membership function will combine all inputs using the union operator. And this operation can be implemented by using the probabilistic OR, okay, like this. So the value of membership C1 will represent the integrated firing strength of fuzzy rule that is from rule 3 and rule 6, for example. Because we have, say here, okay, rule 3 here and rule 6 will have same value of output or the consequence. Last layer would be the defuzzification layer, where each neuron in this layer will represent a single output of the neuro-fuzzy system, where it will take the output of fuzzy set, clip, okay, using the aggregation function by the respective integrated firing strength and combine them into single fuzzy set. So we are going to have one output only. So Neuro-Fuzzy system can apply standard defuzzification process. For example, we use those COG method. So when we say that we use COG method, so we will use the Mamdani fuzzy intrinsic. So when we say that, and then again when we say that we use the Mamdani, we will use the sum product composition method. Like this. Okay. So the sum product calculates the decrease output as weighted average of the centroids of all output membership functions. So for example, we have weighted average of centroid of the clip fuzzy set C1 and C2 will calculate like this, the sum product composition. So how does a neuro-fuzzy system learn? So a fuzzy system is essentially, we know that it is a multi-layer neural network. So it can apply the standard learning algorithm developed in your neural network, including what? When we use the backpropagation BPNN algorithm. So when we train an input-output example is presented, when a training input-output example is presented to the system, the BPNN backpropagation algorithm will compute the system output and then it will compare with the desired output of your training example. Okay, so we have the training and then we have the testing as well. So this is like machine learning that we have learned. The error is propagated backward through the network from the output layer to the input layer back. Okay, and then the neuron will activate the activation function and it will modify as the error propagated. To determine the necessary modification, BPNN will differentiates the algorithm function of the neuron. So this is example of 5-rule neuro-fuzzy system. Okay, so from here in layer 3 of the what we call as output rule layer here. Okay, so we have its value. Okay, and if we take a look at here, okay, so for example R1 will output 0.99 value of the from the weight of the output here. Okay, and then the layer 2 will have 0, layer 3 will have 0.72 here, and so on. This is for training of 50 epoch. Okay, so suppose that fuzzy if then rule incorporated into a system structure supplied by domain expert. So first we have if then rule by the domain expert. So the prior or existing knowledge can be dramatically expedite the system training. Besides, if the quality of the training data is poor, then the expert knowledge may be the only way to come a solution, right? So expert do occasionally makes mistakes. So some of the rules in Neuro-Fuzzy system may be false or redundant. So that is why Neuro-Fuzzy system is doing its learning so that it can capable of identifying the bad rules. So given our input and output of linguistic values, a neuro-fuzzy system can automatically generate a complete set of fuzzy if-then rule. So a neuro-fuzzy rule is actually doing a learning so that it can generate a complete set of fuzzy if-then rule. So let us just create the system for XOR example. So this system will consist of 8 rules. Okay, because the knowledge the expert knowledge is not embodied in the system this time, because we use the neuro-fuzzy system where it learned by the training. Okay, so we will set all initial layer between layer 3 and 4 to 0.5. So after the training, we can eliminate all rules whose certainty factor are less than sufficiently small numbers. So for example, we say 0.1. So as a result, we will obtain the same 4 fuzzy if then that represent the XOR operator here. So this is by fuzzy system where we incorporated 8 rules, and then it will do all of the training. Okay, and the second and the fourth layer will be weighted as 0.5. Then we will eliminate all of the result rules that has certainty factor less than 0.1 here. Okay, so it will give same for output of the rule. Okay, so as a summary, the combination of fuzzy logic and neural network will constitute a powerful meaning for designing intelligent systems. So domain knowledge can be put into a neuro-fuzzy system by human expert in the form of linguistic variable and fuzzy rule. So when a representative set of example is available, the neuro-fuzzy system can automatically transform into a robust set of fuzzy if-then rule, and thereby it will reduce the dependency of our expert knowledge when we build the intelligent system.